The most catastrophic software failures usually begin with a brilliant idea. A user applies perfect logic to your system, they reverse engineer a clever workaround, and accidentally trigger a complete meltdown. Take Pedro. Pedro was beta testing a secure file transfer platform called sgraph Send. He opened his primary web browser, uploaded a file, and the app encrypted it perfectly. Then he opened a second browser to download that same file, but the application stopped him, asking for an access token to decrypt the data. Pedro hadn't written his token down. Instead of giving up, he analyzed the download link. He saw a long, scrambled string of text at the end of the URL and made a perfectly logical deduction. The missing access token must be hidden right there. That assumption is about to start a chain reaction that will baffle the engineering team and completely brick the application. This breaks down a standard URL structure. That complex text at the very end is base64 encoded data. But it is absolutely not an access token. It is an AES 256 GCM encryption key, 32 bytes of raw cryptographic entropy encoded for a web address. Possessing enough technical skill to be dangerous, Pedro reverse engineered the URL. He ran the text through a base64 decoder to extract his missing access token. This diagram illustrates what came out the other side. The decoding produced a chaotic cloud of unprintable binary control codes. Hidden right in the center of that mess was the Unicode character phi, a specialized text encoding symbol used primarily in linguistics. Pedro copied this corrupted binary mess, pasted it into the token input field, and the user interface accepted it without a single format validation check. The initial network layer enthusiastically processed the bad data. It converted the exotic characters into safe, web-friendly text using a standard encoding function, allowing the corrupted token to breeze right past back-end security checks. With the back-end satisfied, the system took the corrupted, binary-laden token and saved it permanently into the browser's local storage, planting it like a hidden landline. Believing he had solved the puzzle, Pedro confidently clicked Upload. Behind the scenes, the application read that corrupted token back out of storage and attempted to package it into an HTTP header, a standard piece of metadata used to send background instructions to the server. This diagram shows the moment of impact. The web browser's native engine strictly enforces an old, rigid character encoding standard written in 1999. It scanned the header, detected that rogue linguistics character, phi, and immediately rejected the entire request. The browser threw a highly cryptic exception about non-ISO standard characters. The application crashed entirely, trapping Pedro in an unrecoverable loop on every page load. It took exactly 8 consecutive failures, combined with a highly creative user, to bring the entire platform down. No automated QA bot would ever decode an encryption key and paste it as a password. Pedro falls into a specific user archetype, known as the reverse engineer. These are technical users who ignore your intended design entirely, preferring to manually pull your tool apart to deduce exactly how it functions. Software teams desperately need these friendly beta testers. They are the only people who will actively venture off the documented path and stress test the strange, unpredictable boundaries of your product. This matrix chart maps out the cost to fix a bug against the stage of development. Finding a vulnerability during a friendly beta costs a team an afternoon of engineering. But if that same bug survives until public production, it turns into support tickets, anxieties, and a massive spike in lost revenue. To properly patch the vulnerability Pedro discovered, the engineering team had to build 4 massive layers of defense, including strict input validation, header sanitization, aggressive error catching, and automatic token recovery. Catching this specific catastrophic flaw in the beta phase shielded the company from a disastrous public relations nightmare on launch day. But the punchline to this whole story is that all of that heavy, complex cryptographic engineering wasn't actually the most effective way to solve the problem. This entire collapse could have been stopped cold by adding a single sentence right under the input field. If the interface had simply told Pedro, "Your token is saved in this browser only. If you switch browsers or devices, you'll need to enter it again," his curiosity would have ended right there. He would have understood the missing token, and the encryption key would have stayed safely untouched. Human curiosity will always be the ultimate system stress test. The true art of software engineering lies in bridging the gap between what a builder imagines and what a creative user actually does.